The twin-cylinder Fétu-Defize is a remarkable example of 19th century steam engineering, representing both technical innovation and historical significance. Built in 1888 by the Belgian manufacturer Fétu-Defize, this engine is a twin-cylinder slide valve design capable of producing 25 horsepower. During its time, such power made it suitable for a wide variety of industrial applications, from driving machinery in workshops to supporting early mechanical processes. What sets the Fétu-Defize apart is not only its engineering, but also its rarity. Few examples of this model survive today, making it an important artifact in the history of mechanical power. Its slide valve system reflects the ingenuity of late 19th century steam engine design, offering a durable and efficient method of controlling steam flow. Today, the engine is preserved and displayed at the Cool Spring Power Museum, where it forms part of an exhibit on flame ignition and early power machinery. This exhibition highlights the transition period in engine development, bridging the gap between early steam power and later internal combustion technologies. The twin-cylinder Fétu-Defize stands as a valuable reminder of industrial heritage and mechanical progress. The Crossley JB Benzene engine is a historical gasoline-powered engine manufactured by Crossley Brothers Limited of Manchester, England. The JB designation identifies it as a benzene-fueled model, with the J referring to its size and horsepower class, and the B denoting liquid fuel operation. Typically built as a horizontal, single-cylinder, four-stroke engine, the JB reflects Crossley's transition from gas to liquid fuel power. Crossley Brothers, holding the rights to Otto's four-stroke principle, were pioneers in the UK, producing thousands of internal combustion engines renowned for their quality and reliability. The JB model, dating from around the 1920s, is an example of this heritage, with surviving engines preserved by collectors and museums. One such engine, number 55792, was auctioned by Bonhams, highlighting its rarity and historical significance in early industrial power generation and engineering development. The 20 HP Street Mary's Oil engine represents a fascinating chapter in the history of early industrial power. Manufactured by the St. Mary's Oil Engine Company in the United States, this engine stands out as a rare and distinctive piece of engineering that highlights the transition from steam to internal combustion power during the early 20th century. Produced around 1915, the engine was designed to meet the growing need for reliable, stationary power in factories, mills, and agricultural operations, when long-term durability and low maintenance were valued above all else. Rated at 20 horsepower, the engine was powerful enough to drive essential machinery, while still being compact compared to steam engines of similar output. What made the St. Mary's Oil engine unique was its use of the vaporizing-cup design, a system that allowed heavy oil to be efficiently burned rather than gasoline. This made the engine economical to operate, since oil was more affordable and widely available. Unlike conventional gasoline engines of the period, it was built to withstand continuous workloads, often running for hours or even days without interruption. St. Mary's engine was also known for its sturdy construction and reliability. With heavy cast-iron components and a slow-running design, it could endure harsh industrial environments. For farmers and factory runners, it provided dependable mechanical energy for tasks, such as powering line shafts, pumps, threshing equipment, or other stationary machinery. This ability to provide consistent power made it invaluable in an era when electricity was still limited in rural and remote areas. Today, the 20 HP Street Mary's oil engine is recognized as an important artifact of industrial heritage. It is considered rare, with only a handful of surviving examples known to exist. Collectors and enthusiasts prize these engines for both their unusual operating system and their historical significance. Museums, such as the Cool Spring Power Museum in Pennsylvania, have preserved and displayed working examples, allowing modern audiences to witness how they function. Publications like Farm Collector magazine have also featured stories about these engines, emphasizing their enduring fascination for mechanical history enthusiasts. Ultimately, the 20 HP Street Mary's oil engine is more than just a machine. It is a symbol of an era of innovation, when engineers were experimenting with new fuel systems and mechanical designs to meet the demands of a rapidly changing industrial landscape. Its survival into the present day ensures that this pioneering technology continues to be appreciated for both its engineering ingenuity and its role in powering early 20th century industry. The Union gas engine, the dynamo, is an early form of power generation system that combines a gas-powered internal combustion engine with a dynamo, an older term for what is now commonly called an alternator. This integrated unit was designed to transform fuel-based energy into usable electricity for a wide range of industrial and community needs. Historically, such systems provided essential power for hospitals, oil fields, factories, and even served as reliable backup sources in critical facilities. The process begins with the gas engine, which runs on natural gas, gasoline, or other gaseous fuels. By burning fuel, the engine converts chemical energy into mechanical rotational energy. This mechanical power is then transmitted to the dynamo, a device that converts rotational input into electrical output. The dynamo produces electricity, typically alternating current, which can be supplied directly to equipment, lighting, or broader electrical networks. In addition to conventional power generation, some systems evolved into cogeneration or trigeneration units. These advanced configurations not only produced electricity but also recovered heat and, with absorption chillers, generated cold for air conditioning, offering efficient multi-purpose energy solutions. Main. While the term dynamo is now mostly historical, the principle remains unchanged. The Union gas engine provides mechanical energy, and the generator converts it into reliable electrical power. This synergy marked an important step in the development of modern distributed power systems. The Dorman V12, often linked to MAN or Dorman engineering, represents powerful V12 diesel engine technology. V12 engines, such as the V12-2000 and V12-1900, deliver up to 2,000 horsepower, widely used in yachts and commercial shipping. Meanwhile, Dorman V12 engines are known for durability in heavy-duty applications, particularly powering industrial generator sets and construction equipment. Whether at sea or on land, the V12 configuration ensures smooth performance, reliability, and efficiency, making the Dorman V12 a versatile choice for demanding environments. Its efficient fuel consumption and long service life highlight its practicality, while easy maintenance and sturdy components make it a trusted choice for operators worldwide. Scharrer and Gross, SUG, was a notable German motorcycle manufacturer in the early 20th century, known for producing reliable 350cc and 500cc engines. Initially modeled on British AJS designs, SUG soon developed its own engineering solutions. The company not only supplied engines to other brands like Hecker, but also built complete motorcycles under its own name. This dual role helped SUG earn respect in the industry. Its engines were valued for their reliability and performance, supporting both its own growth and that of other German manufacturers. Though not globally famous, SUG played a key role in European motorcycling history. The so-called McLaren M4 MK11 diesel does not actually exist in McLaren's history. This name is likely a mix-up with the famous McLaren MP4 Porters, or MP411s, both legendary Formula One machines. The MP4 Porters, built for the 1988 season, remains one of the most successful F1 cars ever, powered by Honda's RA168E 1.5-liter V6 turbo engine. Similarly, the MP411s, raced in 1996, used a gasoline-powered Ilmor engine. Neither was diesel, since Formula One regulations have always required high-revving gasoline engines to maximize speed and performance. Furthermore, McLaren's modern road cars, such as the MP4-12C or the 720S, are also powered by gasoline V8 engines, never diesel. The confusion highlights how McLaren's MP4 designation, used for both racing and road cars, can sometimes be mistaken. In reality, diesel engines have never been a part of McLaren's engineering philosophy. The Dorman V12 is a robust two-cylinder diesel engine designed for industrial and marine applications. Manufactured by W.H. Dorman and Company, a respected British engine builder, it exemplifies the company's reputation for reliability and durability. This engine is part of the DL range, which was developed to meet the growing demand for compact yet powerful power units during the mid-20th century. The 2DL3 is water-cooled and features direct fuel injection, ensuring efficient combustion and steady performance even under continuous operation. Its sturdy cast-iron construction and precision engineering allow it to deliver long service life with minimal maintenance. Originally used in stationary machinery, small locomotives, and auxiliary marine equipment, the engine proved versatile across various industries. Today, the Dorman 2DL3 is valued not only for its technical qualities, but also as a fine example of classic British engineering, often preserved by enthusiasts and collectors of vintage machinery. The 1912-45 HPK steam engine is a remarkable example of early American engineering and agricultural innovation. Built by the Case Threshing Machine Company, this traction engine was designed to provide reliable power for threshing, plowing, and heavy hauling. With a rated output of 45 horsepower at the drawbar, it was capable of handling demanding farm and industrial tasks, often replacing teams of horses. Fueled by wood, coal, or straw, the boiler generated steam that drove the large flywheel and gears, converting thermal energy into mechanical power. Its massive steel wheels and durable frame allowed it to operate on rough terrain, making it a versatile machine. Today, restored Case steam engines are celebrated at heritage shows, representing not only the progress of mechanized farming, but also the craftsmanship of early 20th century steam technology. The 1770 French Cugnot, or steam drill, is recognized as the world's first full-sized, self-propelled land drill. Created by military engineer Nicolas Joseph Cugnot, it aimed to transport heavy artillery more effectively than horses. Built on a three-wheeled cart, it featured a front-mounted steam boiler that powered the large front wheel, along with rack and pinion steering and limited reverse capability. Despite its innovation, the vehicle had major drawbacks. It needed refueling every 15 minutes and had a top speed of only 2 miles per hour. Publicly demonstrated in November 1770, it proved mechanical transport was possible, though its impracticality halted wider use. Still, the Cugnot vehicle marked a turning point in transportation history. Often considered the first automobile, it inspired future development in steam and combustion vehicles. The original machine is now displayed at the Musée des Arts in Paris, symbolizing the origins of mechanized mobility and early engineering